take a look at the first example. Saying that prove that y1 is equal to exponential of minus 2x, y2 equal to cos x, and y3 equal to sin x are the solution of this differential equation. The third derivative of y plus 2 times the second derivative of y plus the first derivative of y plus 2y equal to 0. If so, write down the solution of this differential equation. So, this differential equation is the third order linear differential equation, right? And if you take a look at it, the coefficient in front of derivative of y and y are constant. So we call this constant coefficient linear differential equation. So this one is the third order. For the third order, you can find three solutions for this differential equation, three values of y. Okay? And the right hand side is equal to 0, so that means it is a homogeneous differential equation. In that case, the solution of this differential equation is equal to yc, where yc is a general solution. Okay. So now they're asking you to prove that whether y1 is a solution of this differential equation, and y2 and y3 also are the solution of this differential equation. The way to prove that is just that you just put the value of y1 into this differential equation. If it is equal to 0, that means y1 is the solution, it's one of the solution of this differential equation. And then you do y2 and y3. If they all make this differential equation become 0, then that means they are all the solution of this differential equation. But to write down the solution, the general solution of this differential equation, you got to check whether these three solutions are linearly independent to each other or not. If so, then yc is equal to the c1 y1 plus c2 y2 and plus c3 y3. If not, you just cannot write down yc in that way. Okay. Now, let's see whether it is a solution. We're starting from y1. We know that our y1 is equal to exponential of minus 2x. So we are going to put y1 into this differential equation. But in this differential equation, you've got to do derivative of y1 for how many times? 3 times, because we have the third derivative of y right here. So we do the first derivative, what do we get? What do we get? What is the derivative of exponential of minus 2x? Minus 2 times, exponential of minus 2x. What about the second derivative of y1? Still minus or plus? Plus 4 times exponential of minus 2x. How about the third derivative of this one? Minus 8 exponential of minus 2x. And then you just plug this value into this differential equation. You would get minus 8 second derivative plus 8, right? Plus is minus 2 exponential of minus 2x and plus 2 exponential of minus 2x. Is it equal to 0? These two cancel out. These two cancel out. So you would get 0. So that means it is a solution, right? So that means y1 is one solution of this differential equation. Now take a look at y2. y2 is equal to cos x. So the first derivative of y2 is the second derivative of y2 is the third derivative of y2 is and then you just plug the value of y2 and its derivative into the differential equation. So you would get plus sin x 2 times second derivative of y minus 2 cos x, right? And then plus the first derivative of y and plus 2y. So you have sin x here and there, they all cancel out. And you have minus 2 cos x here and there, they all cancel out. So you would get 0, which is, of course, y2 is also the answer of this differential equation because it is satisfied with this differential equation. Now we check y3. y3 is equal to sin x. So you do the first derivative of y3. What do you get? Cos x. Second derivative of y3 minus sin x. And the third derivative of y3 minus cos x. And then you just plug y and the derivative of y back into your homogeneous differential equation. You would get minus cos x minus 2 sin x plus cos x plus 2 sin x. You have minus cos there and here plus cos x, they all cancel out. You have minus 2 sin x here and there you have 2 sin x, they all cancel out. So you would get 0. So that means by this, that means y1, y2 and y3 are the solutions of this differential equation. But can we write it down in the terms of yc equal to c1y1 plus c2y2 plus c3y3? We're not sure yet. We got to check whether y1, y2 and y3 are linearly independent to each other or not. So we got to check by using Wronskian. Wronskian of y1, y2, y3 is equal to the determinant. Now, this matrix got to be, what is the size of the matrix? 3 by 3, right? So you have y1, y2, y3, and then the second row is the first derivative of y1, the first derivative of y2, and the first derivative of y3. And the third row is just that, the second derivative of y1, the second derivative of y2, and the second derivative of y3. That is your determinant. So you know y1, You know y3. You know y3. You know the first derivative of y1, y2, y3. And you know the second derivative of y1, y2, y3. You know that function. So you just put the function in there. You would get then the first derivative of y1, the first derivative of y2, and the first derivative of y3. Second derivative of y1, second derivative of y2, and the second derivative of y3. Okay, got matrix 3 by 3. So you do the determinant for 3 by 3. What you got to do is just that you write down this is 1, 2, 3. You can write down another 2, column 1 and 2. This is the way that we find the determinant, right? Saying that going down is a positive, right? Going up is a negative. Right? So you've got 3 terms of that. The first term is just that exponential of minus 2x times minus psi x times minus psi x. You would get exponential of minus 2x psi square x. The second term go down, cos x times cos x times 4 exponential of minus 2x. You would get plus 4 exponential of minus 2x times cos square x. The third term is sin x times minus 2 exponential of minus 2x times minus cos x. So, which is minus is a plus 2 exponential of minus 2x sin x cos x. And then the fourth term we go to this side, which is we get negative. We have 4 exponential of minus 2x times minus psi x times psi x. So this whole thing times you would get minus 4 times exponential of minus 2x psi square x. But when you go up, it's equal to minus. So minus and minus, you would end up with plus. You would get 4 plus 4 exponential of minus 2x times sine square x. That is the 5th term. Now the 6th term is that you have cos x here, cos x there, and exponential of minus 2x with negative side there. So we get minus cos square x times exponential of minus 2x, and then you times minus 1 there. Minus and minus, you got plus, you will get plus exponential of minus 2x times cos square x. And the last term, minus is plus. So you got 2 exponential of minus 2x sin x cos x, but you got negative here, so you got minus 2 exponential of minus 2x cos x sin x. Now, this one and this one look the same. You have plus sign, negative sign here, they all cancel out. You have this term and this term, which look the same. So you would get 1 plus 4 is equal to 5, right? You got 5 exponential of minus 2x sine square x. And you have cos here and cos there. You would get 5 exponential of minus 2x cos square x. You see that you have 5 exponential of minus 2x, the same for both terms. To take it out, you would get the property of trigonometer saying that sine square x plus cos square x is equal to 1. So you would get, so that means your Wronskian is not equal to 0. So that means what? If Wronskian is not equal to 0, y1, y2, and y3 are y1, y2, y3 are linearly independent to each other. So that means we can what? That means we can what? y1, y2, and y3 are linearly independent to each other. Therefore, the general solution of this homogeneous differential equation is yc is equal to c1 y1 plus c2 y2 plus c3 y3, which is c1 times exponential of minus 2x plus c2 times cos x plus c3 times sine x, where c1, c2, and c3 are constant. That's the end.